This video is going to look at choosing the appropriate measure when trying to find the average of something. As we've spoken about earlier, there are three main types of averages that we've spoken about. There is the mean, which is the add them all up and divide them. There is the median, which is the number in the middle, and then there is the mode, which is the number that shows up the most. Now, there are good times to use each one of these, and there are not so good times to use each one of these. So let's go over how we can determine when to use which of these methods. So for the mean, if you're going to use the mean, you want to make sure that there are no extreme values in the data. Extreme values, so think something like an outlier, is something that will really mess with the mean and will really affect it greatly. And we're going to look at an example of that at the end of this. But be aware that if you see extreme values, the mean may not give you the best picture of the data. Then we have the median. The median can be used when there are extreme values. You're going to want to make sure that there are no big gaps in the middle of the data. You want to make sure that most of the numbers are relatively clustered in the same area. The mode is a measure that is most appropriate when there are many repeated numbers. So when you see a lot of the same number, that's when you want to look at the mode, and that's when the mode will give you the best snapshot of what's going on. So we're going to look at a couple examples over here. The first example is the number of sea turtles that were observed in 4 different locations. And we see at one location there was 1,033 sea turtles. At another location there were 207 sea turtles. At another location there was 1,332 sea turtles, and the last location had 1,231 sea turtles. Now, because this has an extreme value in it, that 207 is radically different from the rest of these. But there are no gaps in the middle of the data. All of these are somewhere in the low thousands. And because most of those are close together, we would use the median for this data. That is the wrong color. That is not the color we want to use. This data would best be used, you would best get a snapshot of this data using the median. So that would be what you use, because there is an extreme value but no gaps in the middle of the data. The second set of data that we have is the age of students. Now, looking at this, we have a student who's 12 years old, 12 years old, 13, 12, 12, 13, 12, 12, 12, 12, 12, 13, 14, 12, 12, 12. Because we have so many 12s in there, the best snapshot of this classroom, or of whatever this happens to be, would be to use the mode, or the number that shows up the most. If I was to ask the kids in my classroom, oh, how old is everybody in here? And I hear a lot of 11s and a random 10 and maybe a couple 12s here and there, I would say, oh, okay, so most of you are 11. Cool, let's go ahead and move on, because that's the number I heard the most. Same thing here. Many of the numbers here are the same, so we're going to go with the mode, which is the number that shows up the most. Now, when we look at this last section, we have some threatened species, and we know that at the time this data was taken, there are 11 mammals that are threatened, there are 13 birds that are being threatened, there are 9 species of amphibians being threatened, and there are 43 species of fish that are being threatened. What we're going to do right now is we're going to look at this data, and we're going to take a look at what each of the averages would be with and without a certain number. And as you look over these numbers, the 11, the 13, the 9, and the 43, you notice that one of them is very different from the other. 43 is an outlier compared to the 11, the 13, and the 9. So we're going to look at the data with the 43, with the outlier, and without the 43, and we're going to see what changes in there. So, for the mean, if I look at this with the outlier, if I look at all 4 of these, if I add up 11 plus 13 plus 9 plus 43, adding up those 4 numbers is going to get me 74. When I take 74 and divide it by 4, which is the amount of numbers I've added, I'm going to get 19. So the mean with the outlier is 19. If I only look at the data without the outlier, adding up 13 plus 11 plus 9, I'm going to get 33 for that. 33 divided by the three numbers I've added is going to be 11. So you can see that the mean changes a lot with and without the outlier. This 11 represents these numbers relatively well, though it doesn't really represent the 43 because we didn't count it in there. 19 doesn't really represent either one of any of these values because 19 is pretty far away from 11 and 13 and 9, and it's nowhere near 43. The median, let's go ahead and take a look at the median with the outlier in there. So these numbers, to put them in order from least to greatest, are 9, 11, 13, and 43. I'm going to put that work right in a box so that you can see the difference between them. So to get the median of that, start at the outside, work our way in. We have two numbers, 11 and 13. Adding 11 plus 13 is going to be 24. 24 divided by 2 will be 12. So the median would be 12 with the outlier. If we erase the outlier from there and we try to find the median, we're going to start at the outsides, work our way in, and our median will be 11. Let's take a look at the mode of these numbers with and without the outlier. The mode of the numbers without the outlier is not 0. The answer is there is no mode. 0 does not show up more than anything else. There is simply no mode. You can also put NA if you choose for not applicable. Same thing if we take the outlier out. There's still no number that stands out more than any other number. So we're also going to say no mode or NA over here. So taking a look at this information, what you're going to do on your homework is you are going to answer the question of which one of these pieces of data, the mean, the median, or the mode, shows the best picture of this information.